Yeah, so let me just share my screen. Okay, yeah, so I'm Sam, the co-founder and CTO at Oso. I've been using Rust for about 6 or so years at this point. Picked it up while I was doing a PhD in cryptography, and found that I actually really struggled to. I had like some internships and stuff writing C++, and I was falling flat on my face, and sort of was like, it's fine, I'll stay in academia. I don't need to be a programmer. That's fine. Until I found Rust, and I was like, oh, this actually kind of makes sense. And so I've been kind of a fan of it ever since. So when I was starting my own company just over 2 years ago now, I was pretty keen that we'd use Rust, and I think that's been a pretty successful strategy. Okay, cool. Before I get into the meat of the talk, I will say I've got both the Twitch stream chat and the Zoom chat up in a window. So if you have questions, like ask them whenever, and I'll try and answer them like in time, because I think this will all be a lot more fun if people interact as much as possible. Similarly, if you just want to unmute yourself and ask a question, I'd thoroughly encourage it. As much as I prefer to kind of like the in-person meetup experience, I think one of the benefits of everyone being on the video call is that it's a little bit easier for us to all be like interacting on the same level and not just feeling like a faceless blob in the crowd. So I'd highly encourage that as much as possible. Okay, so what I'm going to be talking about today is runtime reflection in Rust. I'll just a few things about the team first. So here's the Oso team. We're 9 people, sort of based part in New York and part remote. I will say as well, we are also hiring for engineers, engineering managers, technical and non-technical positions, kind of a bit of everything. So if you enjoy my talk, then maybe come and chat to me about that. And yeah, we do some stuff in Rust, which you'll hear about today. So basically, what I want to do today, part of this is just I kind of want to show off the Oso products and the piece of it called Polar. I think it's really cool and it's a fun thing to share. But specifically, a big part of this is Rust, and some of the stuff we've done in Rust has kind of delved into parts of the language that I hadn't really had much experience with. I learned a lot in this process of trying to make Rust be more dynamic. It might not be the case that you're trying to do exactly the same stuff that we do, but I think the lessons along the way were pretty useful. So yeah, that's basically what I'm going to talk about today. What is Oso, introduction to this Polar language thing, and how we built the Rust crate. Okay, so Oso itself is an open source authorization system for developers. And one big piece of this is the Oso library. And this basically allows you to make authorization decisions in your application using your application data as inputs. And that's like a very core piece of authorization is, being able to decide like who can do what based on what you know about them. And it's available as a library across multiple languages. So it's just available through regular package managers. If you're using cargo edit, for example, you can do cargo add Oso. Okay, so that's like one big piece of this. And kind of what this looks like in an application. So you express who can do what in the declarative language called Polar. So this is a language we created just for the purpose of authorization. So you can express things like what this says here is, allow a user to read an organization if the user is in that organization's members. So you kind of declare this in the Polar language, and then in your application, you just call this like isAllowed method. You pass in those inputs, and it makes a decision for you. Now, I could fill the time just speaking about like the language and why it's cool and for authorization, stuff like that. If authorization is indeed a thing you're interested in hearing more about, I can come back to that. But just to keep this more on topic, I'm going to primarily speak about the kind of language design piece of this. The core thing to remember here, and I'll like reference back to this like throughout the talk, is this idea that we needed to be able to express this authorization logic over application data. That's what I'm going to keep coming back to. The other kind of like interesting aspect of this is we want this language to be available, this like library to work across multiple languages. So we built this like core Polar language, the policy language in Rust. So that's like this Polar core down here. We exposed it to all the different like host languages. So I'll refer to these like ones at the top, like Node or Python, or even Rust itself as a host language. That's like where the library is. That's if you're building your application, you build it in that language. And we sort of make it possible to embed that core language logic through either a C-style API or through a WASM API. And we just recently added Go as well, which is why I kind of like shoehorned it into this diagram. I think I've lost the graph fizz or the dot that I originally used to generate this picture, so I had to go manual. Okay, so this is like kind of the main layout. And so you can kind of see where Rust comes into it. Now there's like two bits of Rust here, right? There's the core language itself built in Rust, and then there's, if you're building an application in Rust and you want to do authorization, then you'd use the OSO Rust library up here in the top right. Again, another like interesting topic that I won't cover here, but kind of like speak about previously is like how we do this like CAPI layer and how we do these like FFI bindings and stuff like that. So yeah, today we're mostly going to be talking about this, the OSO crate, so the OSO library for adding this to an application. So let me give you a little demonstration of the stuff I just covered there. So first of all, okay, so first things first, I'm doing this in a Jupyter notebook. There is a, I can't remember what is it, EXEVR, I think it is. EXEVR is this it's this kind of like Rust REPL kind of thing. Like it allows you to evaluate Rust dynamically. Well, this is like the core library, and it has a Jupyter extension, which is what I'm using in this, so that I can kind of make this a little bit more interactive and run some Rust codes live as I go. Okay, let me make sure this is big enough for everyone to see. All right, so I'm gonna add OSO as my dependency, and let's clear all my output. Cool. So I'm going to add OSO as a dependency and just like import everything from the library. First thing I need to do is just like create a new instance of the OSO core. And what I can do now is like load in these rules. So this is where I'm loading in the Polar like policy or the rules. Typically, you'd actually import this from a file, so you'd have like all your logic and all your policy in like a single or multiple files, and like load those in separately. But I'm just doing it inline for the sake of demonstration. Okay, so you can see the kind of thing. I've read in a rule which says, the rule is element in list. So I showed allow. It's like this is the rule name. It takes a single input lm, and this evaluates it true if the input lm is in this list, which has 1, the string abc, and a dictionary with a key b and the value 3. So I load that in as a string. This is now inside loaded into my policy engine, and I can now query it. This is like the main two pieces of this. Is you express like knowledge, so you like tell OSO things that you know that you want to be true. You express this in rules and like load it in to what's called the knowledge base, and now you can like make queries about it. You're asking questions like, so in this one, I'm going to ask this question like, is element in list true for the input of 1? So if I run that, I should probably just like run all these while so they compile. I'll queue this one up while I'm talking this through. Okay, so you see I get back like some okay and like an empty dictionary. So basically what, you can see there's like a few layers of wrapping here, but it's like the query evaluated successfully, it had a result, and that result was just like empty. It's basically just empty is like it's true, effectively. There's like no additional information for you to return. Indeed, 1 is like in this list. If I ask, is 2 in the list, then I get like no result back. So this is kind of like the main, we've queried this this rule here, and we found like 1 is in the list, 2 is not. But I can ask like more general questions, right? So I can just ask like what's in the list. So if instead of passing in a concrete element 1 or 2, I just pass in this polar value variable thing, then I can query this multiple times and ask like what's the value of x as the result. And so you see I'm getting back like multiple results here. I'm getting back the integer 1, the string abc, and a map from b to 3. And so this is like the core interface between Rust and the language, right? So you like load information into the language, you load knowledge into the language, and you can query it from the Rust side. And the sort of interesting things happening here is that these types are crossing back and forth between Rust and between the Polar language, right? And so like I express these in the Polar languages as one, and this, gets returned back as this, like, this is a variant, basically the integer one. Okay, so that's like the main interface. So runtime reflection in Rust. What is this topic all about? And I should say this is like the content I'm going to talk through in this talk is kind of like a short version of some of the things we covered in more depth in our blog and like a series of installments on how we actually ended up building this. But it kind of comes down to these three things: classes, attributes, and methods. These are sort of the three main pieces we needed, and I'm going to speak about why. So first things first, so the rule I showed you previously was kind of simple. It was just like check min elements in a list. Now, one of the things that makes the language incredibly useful is that we can actually do some amount of like type checking, right? So you have this syntax here where you have an input and you can do colon and the type. And this rule only match if the input you pass it actually matches that type that you expressed. And so the reason this is useful is then you can have like multiple rules, for example, and you can pass in different types, and you're basically getting like a form of like pattern matching based on the type. So what does this look like? Okay, so here, for example, maybe I should just like queue these up again. So for example, right, in Rust, I have a cat struct, and maybe I want to like, I now want my policy to be able to answer questions about cats or not, checking things, is this a cat? And so this is just a kind of a stupid rule, say this is a cat, and it's checking that the input type is a cat. I can actually leave off this if, that's kind of redundant at this point. This rule says this is a cat, and it's just checking that the input variable matches a cat. I can pass in one, right? So I query the rule, this is a cat with input one, I'm going to get back none. Whereas if I actually pass in a genuine cat, I get back, a result. So the type checking here isn't quite like, Rust checks, it's not going to compile if you pass in the wrong types. It's actually used for this like rule selection process. And the idea is like you could have, for example, I could express this rule differently. Let me show that now, actually. One of the different things about this being like a declarative logic-based language is I can have multiple of these rules, and basically what the policy evaluation will be doing is going through all the possible rules and asking which one is like which of these would be true. So I could actually rewrite this as something like this. So I have like three separate rules. Each one would be like individually checked based on the input types. Or I could write this like check that it's an integer and check the integer is equal to 1. Or this is input, check the input as a string, and the input is equal to ABC, things like that. Again, I don't want to like go too much into like the authorization stuff, but like this is very powerful in authorization because it allows you to ask authorization questions over different input types. So if you have like two data, you can kind of write rules over either one. Okay, so we needed this like ability to do these kind of like type checks on the inputs. And this is kind of all about like dynamic classes because, as you saw, I passed in one, I passed in cat, and the Polar language had to make at runtime a decision on if that was true or not. So anytime you need like dynamic classes, you're probably talking about some form of like traits, basically trait objects, that kind of thing. And so this is like pretty useful trait called the any trait that sort of allows you, as it says here, right, it kind of emulates dynamic typing. It effectively allows you to throw away the concrete version of the type that you have and just like pass it around as just like this could be anything. You're sort of in, you're kind of in like JavaScript land, everything's an object kind of thing. So here, let me show an example of that. Okay, so suppose I start out with this nice string, hello world. I can basically like erase the types of this string by boxing it and casting it into this like dynamic any trait. And this is basically this is kind of saying like this is now just some some value that's stored and it could be anything. So in particular, because it doesn't have like a concrete type, like I can't print that. It doesn't make any sense to me to try and print any because, as it says, right, any doesn't necessarily implement display. Like I don't know what it is anymore. But it's not like we threw away the type and it's gone for good. So the any trait has this basically just this one method, and then like other things are kind of derived from that, which it does actually carry around effectively what the original type was. It still kind of remembers that. So in particular, what we can do is we can actually downcast. You can use this downcast method. This is actually on box. So you can go back from the any trait back to your string. One thing to point out, this is fallible because we're now like into runtime dynamic behavior, right? So Rust doesn't know that this, Rust isn't going to like track at compile time that we any'd it and then we've got it back. It could be anything for it. So this is like at runtime fallibly, I'm trying to convert it to a string. But once I got the string back, I can call string methods on it and print it out again. And it kind of turns out like this is sort of the main. This is like the main implement that we needed to sort of be able to emulate dynamic, runtime dispatch and classes and things like that. And so this one I'll come back to in a second. Okay, so what this basically led us to is, and the kind of implementation we have is, we're starting to emulate this dynamic class system like you might find in other languages like, say, Python, and we sort of treat the type as it's kind of like a class, and this like boxed any trait is sort of like an instance of that class, and with those kind of two pieces, you're almost into this into like a nice runtime dynamic world. The only difference is like we don't get like everything we need. Like everything we kind of need to do to do like dynamically interact with those classes at runtime from this like box dyne any and from the type information, we need to do a little bit more work. So in particular, what about dynamic attributes? All right, so again, like coming back to the authorization use case, like you might want to check like, is the user the owner of this piece of data? So we're gonna like, I pass in some data and I look up the owner on it. Right, so this is all about like accessing attributes on the struct that you pass in. Now, there's a question like, why is this hard? Like, why isn't this just something you can like naturally do in Rust? And I mean, it's like more complicated than it's like Rust just doesn't want you to. So if you have like a struct, Rust doesn't give you any guarantees about the layout of that struct. It's sort of, and this is an optimization on Rust side. It's free to reorder, move around fields to if it wants to like pack them into the most efficient layout. It realizes like, oh, you got a ball and a U32 and another ball. If I like switch those around, I can actually like lay this out more efficiently. Rust kind of reserves the right to rearrange your structs like it wants. So you're not just going to like have your fields at some like known offset. You can kind of like override this. This is what like the refer C thing would do. It's like, no, just behave more like C and just like leave them in a standard layout and things like that. But like, suppose you don't, as for us, like as the creators of this library OSO, we don't want to say you have to like add refer C to all your structs so that you can use OSO. Like what's left for us? So we kind of like looked into all of the different ways that you might be able to, at runtime, look up the attribute on a struct. And basically, I think the thing that like originally occurred to me was like, well, maybe this is like a SERDI style thing. It's like I want to be able to leverage something that can already like walk over all the fields of a struct and maybe like convert them to the right types. Like that felt like it was maybe the right thing we needed. Like if we could like serialize the struct into JSON, say, then that's kind of like a dictionary. We can just like read things off it automatically. That one I didn't like in particular because it's sort of muddying the water between like, are we doing serialization or are we doing like reading attributes and stuff like that? So there's like a few different like options we tried. None of them quite seemed right. So we went for something that we felt was the best balance for kind of usability, but kind of staying true to Rust, which is like being more explicit around like an attribute getter. So the idea is like an attribute getter is effectively a function that you provide that you give OSO to tell it how to look up a field on a on a struct. So what this looks like is like this down here. So basically, I guess I should have said this earlier as well. Like when, like the way that Polar knows how to handle, like in this case, I had above with oh, my scroll is going crazy. So before, like the way that Polar was able to know like what a cat was in order to do the type check-in, we basically had to register this class with OSO, and so there's like a few helpers to like do some of the generation for you. This is basically where we're telling OSO like, here's what a cat is, here's how you do checks. And so similarly, so now like, you know, to look up attributes, we kind of ask you to do a little bit more work. So we basically say, you tell us how to look up the field X. And there's like a very simple method for this where we pass in the name of the attribute getter, and you give us like a function or a closure or something on how to get that one. Now, there is intentionally a little bug in here, which I left in to show off kind of a nice property here. The type signature of this add attribute getter is expecting that you actually do pass in something on foo. Like, so if you have a struct foo, it's expecting you to actually look up something on foo, because we're going to do some of this like dynamic check type lookup stuff. So I actually need to make this a foo in order to be able to look it up. And this could be foo.x actually. Okay, that's kind of fun. So you see, like I was returning 1 here. So this is saying every time you look up x on foo, on any foo, just return 1. My rule was going to check if this is a good foo by seeing if foo's x field is 1. So that was true in both cases, even though x was different. So I wasn't actually looking it up correctly. What we really want this to work like is like this, right? So so again, here we have the policy logic. So I've got a rule is good foo, it takes in a foo, types check that is actually a foo, and says this is true if the lookup of the x value on foo is equal to 1. And so, you know, if we set x to 1, this gives a result. If we set x to 2, this gives none. And so like this is now already getting like pretty powerful, because we've effectively extended our like Rust implementation with this, you know, entirely new language, which allows you to write, you know, logic-based rules and do logic-based programming like inside your Rust code, over your like native Rust objects, over things like structs and integers. This is not like loads of fun. So the proc macro like has the ability to, you can say like, this is a Polar attribute, and it will just like do this work for you basically.
I have a question.
Yeah.
Is Polar the global namespace, when you register a Polar class using the derive, like is that going to override other existing classes if you have the same name in your project? Like how would you differentiate? Yeah,
it's a good question. So the derive doesn't, so there's no like global, I'll come back to there's no global later. There's not really a global. You'll see like we still need to do this thing where we get like the foo class, we construct the foo class, and then we register it on a single instance of OSO. If now like part of this get Polar class builder, by default it's setting like the name it's registered as to foo. You can also like override that. Like I think it would be like .name, I think, if you want to like tab foo too. Right, currently it'll default to the name of the struct. If you have like multiple, you can always differentiate them if you need to, or things like that. Does that answer the question?
Yep, thanks.
The slight caveat, the slight exception around the global namespacing thing is if you, I think we kept this in. If you attempt to use a class that, or a struct that you haven't previously registered, but it has a valid implementation, we will try and use that for you, basically. So there's like a little global namespace that it'll fall back to if you forgot to register a class. Okay, so that's attribute getters. And so again, like, so this is kind of the core implementation. what was really nice about this is we're kind of doing all the dynamic pieces here, right? So you can see like as an input, it's taking this like reference to an instance. Actually, let me go through the code because this bit's kind of fun. So here is this mysterious instance. So it's slightly different to what I was saying. It's not box, it's actually arc. So we can like clone it around freely, but it's pretty much, just mostly it's just made up of this inner type, which is just our like fully dynamic, like type erased thing that we pass around. And so the idea is, and this is kind of like the thing that we interact with inside the code base as we pass these instances around. What I'm like one thing that I'm really happy with around like how this turned out is as like an end user of OSO, you don't interact with this at all. You had an attribute getter and you pass it in like pretty simple like closures or functions over your like types. And you don't need to like interact with this weird like instance and dynamic class system. We kind of do like the shims in the right places to make that all happen. Okay, so the final thing I want to talk around is dynamic methods. So whereas before we were doing like foo.y, what if we have like a method we want to call? And like on paper, this is almost the same as attribute getters. We were already using closures to do the attribute getting, right? You need to give us a function that would take in your foo instance and return your foo.x thing. So really, and if you're familiar with like Ruby, for example, Ruby really does make like attributes and methods with no inputs basically the same thing. There's not too much of a difference between attributes and methods. You just have like an additional set of inputs. At least at first I thought they're basically gonna be the same. And so like when I started out, I was like, well, maybe I'll just like have this nice function trait that allows me to that'll like handle all of this. Like, I pass in a list of values, and I just basically need to make sure I call the function, the method that I provided, to call it on those arguments. Now, this didn't quite work, and this led me down this kind of like path of learning something about Rust that I'd wondered about for a long time. So I thought it was kind of an interesting thing to share. And I think I kind of encourage people to share failures. I think it's more fun. Okay, so here's like a sort of somewhat, here's basically the same kind of trait I was talking about. And so basically, the idea is that like someone could pass in a method and we'll like wrap it in this trait so that we can kind of call things dynamically. Right, so the idea is, we can have like an inputs coming from Polar, and we can like dynamically call a method on it. Actually, I think I want to be doing it on this one. This I think is my other example. Yeah. Okay. So like this. So this was like the original attempt, and this was like the weird result I was getting that like confused me for a while and I'd seen before, where it's telling me that like A and R are not constrained by this like impl trait, self-type predicates, which was weird to me because I was like, well, aren't they like specified right here? F is a function from A to R. What do you mean that these are like unconstrained types? Like, they're present inside F. It took me a long time banging my head against it and trying various different like workarounds to make this work. So for example, I was like, well, maybe this will work. And here I don't need the full trait to make this work. So here's just a faked out trait. Maybe I can make it work over just like these function pointers or like dynamic functions. So I'm going to implement my trait like that. And let's try it out. Okay, so like what if I try and treat, here I have a closure which I was expecting would be a function. Like, should this work? And it's telling me, the trait is not implemented for this closure, which I'm like, okay, that's weird. Like, this looks like a function that takes in one input to me. Shouldn't this work? Okay, well, like maybe I'll try this with a proper function. Like, this should work. This is definitely a function. But again, I'm getting the same error, right? My trait is not implemented for a function which takes in a U32, and I'm like, well, function A, function U32. many hours wasted like trying to understand like what I did wrong. And of course, like the example wasn't this simple. It was like with all this other stuff happening, so I couldn't really see it. And the hint is, well, the hint is what it, this like square brackets thing for, the whole closure, or this like little curly braces test fun. So basically, Rust closures like this one in here and Rust functions like this one here are not exactly the same thing as a function pointer. They have their own like unique anonymous type, and that's kind of what this is trying to hint at a little bit by giving this like curly braces structure, is saying this isn't a function pointer. This is like the function itself. Effectively, it's a type for test fun. You can't just use this in the same way as a function pointer. And I think, again, this is actually like a sort of an optimization. You don't need to like deref the pointer to find the function address itself. So instead, like it's like it is almost a function pointer. It just like needs to be coerced into one. So that's what you can do like down here. So I have the same closure again, and I try and do the same approach. I try and treat this as a box version of my trait, and now it'll work fine. So basically what the problem is that these functions just need a little bit of like coercing to go into the function pointers. So then they'll actually implement this trait. So this was sort of like a bit of a rabbit hole. From like the original intention was just like you can pass in a function and like we can dynamically deal with the input arguments. And I was like, okay, well that didn't work. So maybe we can just like do this straight up with a function thing. This didn't work for different reasons, and I was like, and we felt like the UX of having to, write this like long thing out every time you wanted to pass in a function was like not acceptable. So then we came back to this original problem, like why this wasn't working, and it came again. This was again where I had a chance to like really understand a little bit better what was actually going on with Rust traits and things. And basically, what Rust is trying to tell me here is if you implement this trait for F, then we're sort of we don't know exactly which. It's possible effectively that there are like multiple trait implementations that match this for like one thing. So let me. I think I've got an example somewhere. Let me just look this up. So basically, like imagine we had a my test function again. It had like a generic input X, and whatever like the code goes in here. Then you can imagine that this test function with X actually does implement function for all values of A. So if basically Rust isn't going to be able to know like what you actually need to like what A should it be dispatching on at when it's trying to like choose a trait implementation to use. So the thing to do to address this, basically, if you see this kind of error where it's like unconstrained types around this, is move them up into like generics on the trait itself. And this is basically making this all like nice and explicit. So it's like I'm talking about a function that gets called with this like set number of arguments, and then you can kind of get around that problem. Yeah, so this was like a temp number. I don't know what. There's kind of a lot of missteps and frustrating times trying to work this out. Yeah, and actually, okay. So there's like one kind of problem left with it. Like problem left with this though is that the dream of the original one was that I could just write this one trait, and this would cover like you can give me any function and I will be able to like make this work with dynamic dispatch. If I have a list of values, I'll like be able to look up the function and call it. The subtle difference going to this one is that you maybe need to specify what the arguments are. And so in particular, what this ended up having to look like was to make this trait available so someone didn't need to implement this trait, we want this trait to work over like all possible functions. But we need to do it for every different combination of like argument inputs. And so that's where we went down the sort of macro path you get one of these great things where the sorry, so yeah, like if you see like the macro up here is kind of like filling in all the blanks of like for all the different like letters I input, I'm gonna like implement this function trait for fun, where fun is a function from that number of inputs to things, and it's just like filling on all the macro. It's going to basically generate for, this macro is going to generate for every number of inputs from 0 to 16 or so. Yeah. It's going to generate this like macro, this trait implementation for a function accepting that number of inputs. And so like, this is what then ultimately it's going to allow someone to do, all of this just to make it so that it looks like this basically. So, imagine I have my struct bar. It's got some method that accepts, an integer input, outputs an integer. I can, again, with this like class registration thing, just do add method with add things. Whereas, this is what it would have had to look like if we hadn't have done all this like trait magic and like, implement the trait for all the different function inputs. Instead, the like end experience is just gets to do like bar add things. And like under the surface, what we're doing when that happens is kind of some of the shenanigans where you can see like, if I find the, yes, so here's where we define this like instance method, which is where we kind of like, the type value we have for these like dynamic methods. So you pass in anything that implements method, right? So that's the trait I was just walking through that we implemented for like functions of multiple arguments. And then basically we like wrap it in all the dynamic stuff. So, we're making sure that if the receiver type is this dynamic instance, that we downcast it. We know what type we should be downcasting it to when we create this closure, because it's coming in here on the method trait as this T generic. We can convert all of our arguments from, polar types back into whatever this like argument list needs to be, right? So if your method accepts an integer and a string, like we need to convert them both back to an integer and a string. But this is all like the type conversion here back to your method is done at like compile time. Or rather like this list of args would be known at compile time. And then ultimately, we invoke the method. So we have like all these layers like wrapping, in the core you have your like nice strongly typed function, accepts like a known number of types. And then we have like the thing that we expect on the polar side, which is that you can just call a method like fully dynamically with some kind of runtime instance and some list of values. And then we have this like shim layer, which like bridges the two, where it's, at runtime converting the types, but like you have this kind of like extra layer of safety, which is that you, through the type system and through the traits, you know what they should be converted to. So it'd be kind of surprising if any of it, like it'd be very, very difficult to like somehow make this be false, that you've like called a method on the wrong instance, because we're kind of doing that bookkeeping. Okay. There's some like other bits and pieces that I won't go into too much depth unless people are interested around like how we did class methods, and we kind of like copied there's like a sort of Pythonic approach of treating classes themselves as instances of like the meta class, which is kind of fun, and like how we handle things like iterators and results. Yeah, those are the main things I want to cover. It's interesting, like when I was doing some research for like this, the kind of the blog entries in this talk, I was kind of seeing if like this kind of thing has, other people have been trying to solve these kind of problems, or like, similar things existed. And interestingly, I think it's something that comes up quite frequently if you're trying to build something like a language on top of Rust, or even if you're just trying to like, maybe the Python itself is, maybe the language is Python, and you want to like interact with Rust types and like the Python interpreter. You get into this world of needing to like casting this dynamically. And it's kind of interesting, because if you look through all of these, you'll see very, very similar patterns of doing this like dynamically, wrapping functions in args and all this kind of stuff. Cool. So yeah, here are just some links. I'll drop them in the various chats to avoid people from having to Oh, and click on it apparently as well. To avoid people having to type them hurriedly. Here we are. Yeah, so if you want to like learn more about OSO and what we're up to, you can go find our website, which I accidentally just previewed there. All of the code, everything I've been talking about is part of our open source library. So this is all available through GitHub, and you can see what's going on there. We have a Slack channel for the OSO community. We talk about authorization or Rust or anything else. And yeah, we have to take any questions that people have, like go into more depth.
Sam, I just want to say thank you, but I do have a quick question because I am actually currently trying to use OSO.
Yeah,
why is query rule immutable? I have the case where I'm trying to execute the engine on handlers, and I don't have to reinstantiate OSO every time because a blocking like mutex would kind of suck.
Why? So sorry. Why is query rule?
Like, why does it require OSO to be mutable?
Yes, because yeah. So basically because when you're creating a yeah. Wait. Why does it require it to be mutable? Now I think about it.
I mean, I feel like now maybe I messed up and it's not mutable, but
nope, it is absolutely mutable. I feel like it shouldn't be. I think you're right.
All right, well, I guess that's a bug report then.
Yeah. Because like, okay, so like I'll explain the like overall model first. Typically the way it works is that you have a like a single OSO instance that will be shared across your entire application, and you load rules and stuff, and you can register constants, and all that would happen inside the OSO instance. You to actually like evaluate it, to run a query, you create a query object, and that is effectively like now something that you can like run on its own thread. It's like it interacts with the Polar core, but it does that through like locks and stuff. So the idea is you'd have like one shared OSO instance in your app, and on like every thread that you need to run this, you can run a separate query. And actually since we have Nikolai here, that's why we have this like static assertions thing here to make sure that like OSO does stay thread safe. It's kind of a nice little check in here, make sure that this is actually safe to share across threads. So in theory, yeah, because this is happening on the arc, and this is cloning the host up front. Huh. So why did Rust not tell me this doesn't need to be mute? How dare it? Yeah, sounds like a bug report to me. I mean, you can basically, I mean, you can just like also clone this, but it would be a little bit of an additional redundant clone. No, I guess you shouldn't be cloning it because the host is gonna, then the host might get out of sync. Yeah, good catch. I suspect that's a leftover from, we reworked some of the internals of this. Yeah.
And so now I have a question just about the whole runtime reflection itself. What's the overhead?
Yeah, it's actually pretty minimal. I mean, it's like we have benchmarks like over the system, like checking on I can probably look up those actually. So like here's like the core benchmark to check the speed of the get attribute lookup, for example. I think this should be available here. Oh, this one might not get published with everything. This one doesn't get published with the benchmarks here, but it's It's surprisingly not too bad. The query evaluation itself, like we still have like ample places where we can optimize the policy evaluation and stuff like that. The kind of we've mostly been focusing on like correctness of the system, especially for like the case of making authorization decisions. Like we were, prioritizing it, making correct decisions and in like fast enough times that would be like acceptable for like a typical request path. And I'm trying to remember. I did used to know the numbers. I think they're like the like dynamically checking the downcast, the like casting sign to any and downcasting back is normally like I think it was like 10 microseconds or something, that kind of order. I think I have it in the blog post somewhere.
I'm curious, as an optimization, have you considered having an unsafe method where you can have like a pointer offset to get a field? And if so, like, have you seen what the difference is as opposed to like creating the arced function?
Yeah, and I haven't actually compared that yet. So just to say what you're talking, just be clear on what you're talking about, right? Like, so basically that would be like if you did like reference on it, right? Then you like know exactly, if you had a pointer to widget, you'd know where to get like the ID field.
Yeah, I mean, there's also a macro to get like the offset of a field. It's currently not technically sound, but enough crates use it that breaking it would be really bad for the ecosystem.
Oh, interesting. Yeah.
So just something to consider. And with the const evaluator, you could actually create like a const value for that. So you wouldn't even have to like do any like runtime thing.
Oh, that's cool. Yeah, I think that could be worth trying out. I mean, I kind of teased this at the beginning a bit, but like my ideal version of all of this is that we just did the, we constructed all the reflection stuff at compile time. And there's kind of interesting, I know D. Tolney was working on this for a bit, but someone else has picked it up the work, I think. Oh, it's been updated finally. Every now and then I check back on this and it's never been updated. So this is like a really interesting approach, which is it basically provides like a reflection-like interface for proc macros. It took me a long time to like wrap my head around the fact that that's what was happening. But basically it uses proc macros to allow you to, where's a good example? Yeah, so like take this, for example. So you get to write your like proc macro using, writing this in Rust and everything, and it sort of looks like reflection. You're like, get me the 0th arg, get me the first argument, things like that. And you're getting back these like reflect values. You can like switch over the data type and do different methods based on what is in it. But all of this is just a shiny interface to everything you could do yourself in a proc macro compile time, right? Like you have, it's reasonably straightforward to write a proc macro overstruct that like reads the fields. And so indeed that's what we do in like the polar class one. Do I have an example of it? No, but like we basically we made this as like opt-in, but basically the proc macro like walks over all the fields of bar and like decides whether it wants to like provide implementation of looking up that X field. It's like we do that, but what this like reflect library basically gives you is like a programmatic interface to do that in a sort of more principled, structured way. And yeah, it kind of goes beyond that into being able to do things like what looks like runtime reflection, like dispatch on methods or even on traits. So I think this is like I know this is one that I've like tried to find out before, which is you want to, like, I think the idea of this example is like if you want to conditionally do the like printing of something, I don't know, I wanted to do this a bunch. It's like if it has a print implementation, use it. Otherwise, just like print out some placeholder or nothing. And this is the kind of thing you just like can't do typically in Rust. This like example here gives you something that kind of looks like that. It allows you to write an implementation that sort of works that way, and like fills in the implementation of like debug for you. So this is I think would be the most interesting or like promising thing for us to do next. And like the reason this would be, like one of the reasons this would be so powerful is like we often talk about the policy code you write. So like you express your authorization logic in Polar. It's something that should be like static alongside your application. Like it kind of changes with your application. It's not like dynamically modifying that is just the same as like dynamically modifying your application code. So it kind of would be like consistent with that if it was all happening at compile time. It's I've just been waiting for this library to mature before I try that out, because yeah, it hadn't been updated in a while, and every time it's a proof of concept. Oh, actually, wait. So this one has been updated, but not the other one? Interesting. Yeah.
I also know that Bevy is working on a reflection system.
Ooh. Is that GitHub just Bevy as well?
Yeah.
No.
Probably Bevy Engine or something,
Yeah.
right? Yeah.
Yeah, it's under the Bevy reflect crate inside of Bevy.
Nice. Oh yeah. Yeah, I'd so much rather we could just use someone else's version for this. Maybe we'll try and contribute to this instead.
Yeah, it might not have the exact same goals as what you're looking for.
Yeah, it seems like it maybe doesn't support methods right now, but it does support getting fields, which is pretty important.
Yeah, I think it supports fields and maybe traits. Like
Ooh.
you can reflect traits, but I don't know if that's useful for your project.
Potentially. Yeah, that actually be nice. So like when I showed that you can in a rule use like the class as like a type check, it would be kind of nice if you could do it over traits as well. Like it makes sense. We do it more in like Python. It makes a lot of sense because you might have like resource subclasses and you want to like match on the like base type, things like that, which isn't quite so common in Rust, but could make sense to have something like that through traits. Yeah. Cool. This is yeah, this looks interesting.
Bevy is also under extremely active development. So, if they like the changes, they want to bring them in, there's a good chance they'll be brought in decently quickly.
Yeah, that sounds good. Arctic Space Fox in Twitch says, I don't get Bevy. Does someone want to give a description of what Bevy is and what it does?
Bevy is I guess like a modern, it's a data-driven game engine made for Rust. It uses, I can't remember if I think it uses Hex ECS behind the scenes, but I think they forked it and created their own version.
I think it was inspired maybe by Hex. I don't think it's actually a fork of it though.
I noticed a Bevy Hex crate in crates.io. So I don't know if that means if they're still using that one or if that was like an early prototype.
I know they are rewriting it in a ECS version 2, which would be pretty interesting.
Does anybody else have any questions?
Yeah, I have a question. It's a bit side, but you had on the screen briefly some nice looking benchmark graphs, and I want to know more about those. Is this like running the same benchmark on your crate over time?
Yeah, let me pull this back up. Yeah, so you're talking about this.
Yeah.
So
I want this for my stuff.
this allows me actually to go and brag about our CI line, because it is somewhat insane, because we're basically building packages, right, for multiple different languages. Let's see, this is the one.
Whoa.
So we build, we have the Rust core, and I showed the 6 different host languages we currently support. Because we have the Rust core, we basically need to do a lot of building the binary distribution. So for example, for Python, we build for every different Python version a statically compiled version of the Rust core and build it into a wheel, and then we test and validate that all those were successful. So this is kind of part of our monstrous CI chain. The benchmark stuff in particular, it's regular criterion for the Rust crate for benchmarking, which is pretty great. So it's just using the regular criterion crate for doing the benchmarks, and I think this works with other Rust benchmarking tools as well. So this is all just straightforward, and then on top of that is a GitHub action for running the benchmarks and creating that nice graph and stuff.
So you're running benchmarks on GitHub Actions. Do you run into issues with VMs being paused and restarted?
Not paused and restarted. I mean, we kind of joke that this is effectively a graph of GitHub Actions performance over time. It's the I'm pretty sure this slope isn't really us. It's probably just seeing some degradation in GitHub. But you do, when we make substantial performance improvements,
yeah, that's
in here somewhere. These are kind of main. So we this wouldn't be very useful, I think, for call them 1 or 2% optimizations, in that kind of range. We use it for primarily as it's another form of test. We want to make sure there's no substantial regressions, way more than we're expecting. It catches them, stuff like that, and it can be nice to see some things over time. But definitely on the small scale, you will see some of these things going crazy when you don't touch the Rust code. Someone's going to post a 1-line docs change, and suddenly you're getting crazy extra performance. But it shows you some amount of trends over time, and if you're doing benchmarking work, it's kind of fun. You can mitigate that if you ran this on your own hardware. I think that would, I think it's pretty possible to do that with GitHub.
Okay, so can I run over it one more time? Use GitHub Actions to spawn benchmark with criterion.
Yes.
But I missed the part of where you're making the graphs.
Okay, so it's these 2 jobs. So step 1 is we're just running cargo bench, and we're outputting the format in specific in the Rust bencher compatible one.
Yeah. Okay.
So that's piece 1. Piece 2 is this magic GitHub action.
Oh, okay. That's where the magic is.
Yeah, this is the. Let me put it.
A coworker that is going to be eating this up tomorrow.
There we go. Yeah,
right.
And it supports a few things. It's pretty nice actually, and it creates that. And basically, what it's doing is it's just pushing a JSON blob to a GitHub Pages page. So it's not there's no hosting to do. This is just on it's just pushed into a GitHub Pages branch in a JSON blob. It's kind of nice.
Awesome. It sounds so slick.
One big caveat. It does some other cool stuff. It can also comment on PRs if you exceed a threshold.
Yes.
The big caveat to that is you cannot run it on pull requests safely. Which is why you'll see it commented out here, because it needs to be able to comment on a PR. It needs to have your GitHub credentials, and because you are running. Just because you're running anything, basically, in this case, I can't remember what was the. For example, the fact that you're running cargo bench means that someone could open a PR, basically write arbitrary code into your benchmark, and then publish your GitHub secrets everywhere. it's sort of unfortunate that GitHub doesn't make it very easy for you to run like kind of like untrusted code on PRs, basically. But if this is just on like internal things like pushes, you can do it. You can do it for all your internal things. It's just if you only wanted it to happen on like pull requests, it's kind of hard to make that work.
Oh.
Yeah, which we haven't yet worked around. The way you have to work around it is you could have like two jobs. One like outputs and uploads the artifacts, and you can have like a workflow dispatch event. You can have like another workflow like listening to when the PR is run, but it's kind of a mess. So it's not ideal.
Oh, yeah. Very cool. Thank you for sharing.
No worries. Yeah, the benchmark piece is pretty cool. It's good for like on pushes.
Any other questions?
Yeah, I have a question. So I noticed earlier in the OSO language support photo that Node.js was the only one using a WASI module. So I wanted to know why I wasn't using the Polar C API.
Yeah, so what it basically allowed us to do is we sort of technically, not officially, also support running OSO in the browser, which is a lot of fun. Mm-hmm. And that's basically possible because of the WASM thing. We just have basically two different compilations of the Polar WASM module. One which is like for Webpack, which makes it easy to run in, produce for the browser, and one which does it in the like Node format. I think like part of the original motivation for using WASM was I was expecting it to be way easier to like share and expose types across the boundary. Mm-hmm. Like I was like, oh, this is great. Like it will basically just be, I can write my native Rust code, I can part to WASM and just like basically import the type straight up in JavaScript in Node and not have to do any like linking and stuff like that. So I mean, we cut out the linking piece. Like we don't need to compile it for different platforms and link it in and stuff like that. But we still have to we still force all of our Rust types to go like through JSON to get deserialized back on the Node side of things. Because like the type interop across the WASM boundary is still not amazing. But it's at least reduced the number of different packages we need to create for Node because the WASM one just works on all platforms, which is kind of nice. And in the browser. Actually, one other thing, I was hopeful that we'd be able to get similar benefits in other languages that have WASM integrations. So like in particular, I was expecting that we could use this in like Go libraries pretty cleanly without needing to do the like C API in Go. What I learned is that compiling Rust code to WASM to use in like other languages is still like very, very early in this whole like specification effort around defining like interface types for WASM, like between languages, which right now is missing things like strings. So you can't even you can't out of the box like compile Rust code to WASM and then and pass like a string across that WASM boundary between two languages. It's sort of something you have to do. You have to like manually create strings by like allocating the WASM memory yourself and interacting with the arrays and stuff like that. So it isn't really I know it holds a lot of promise to make interrupting languages super easy, but it's got a little way to go still. If you're doing stuff outside of JavaScript. If JavaScript's your target, it works great. Yeah.
I know that 1Password is using WASM to interface across different languages, so maybe you can read into what they've publicly stated about it.
Yeah. Nice. Yeah.
Yeah, because I'm guessing for other languages that might make the workload easier than wrapping a C API every time.
Yep. Yes, it would. Cool. Yeah, I'm making a note of that for later.
So I have a question for OSA itself. Is there a feature in like JIT compilation or like maybe outputting to crane lift or LVMIR?
For the language itself?
Yeah, so like right now it's kind of walking a tree, right? When it executes. It's not necessarily like a bytecode.
Yeah. So the evaluation, yeah, I mean yeah, it's sort of more of an interpreter than a compiler, the language right now. How to answer this in a way that's gonna make sense for everyone. I'd say the kind of the main effort, the main work we're doing in that direction is around partial evaluation, and let's see what I can do as give me the best way to give an example of that. All right, this is going to maybe be a little bit abstract for people. Oh wait. Let me bring this one back. Okay. So, all right, I'm in the Polar REPL for Python, so I can write my I can write my Polar here, and like this is kind of like querying it in one line. So, for example, I can say like, what are the solutions for x is in 1, 2, 3, where x is greater than 2, and I'm just gonna get back x is 3, right? And so this is what this is like the core evaluation of Polar is it's going through this and evaluating, and it's sort of like a search algorithm. And so like I can turn on the Polar log and write that again. And you can kind of see that it's like executing this search algorithm, right? So it's going to go through for x is 1, 2, and 3. Is 1 greater than 2? Is 2 greater than 2? Is 3 greater than 2? So that's like the core execution of of how queries are evaluated is like goes through this like search algorithm. Now, one of the coolest things we're doing recently is around partial evaluation, which is kind of allowing it to do these to return results even if some of the inputs are fully unknown. So if I was just to say x is greater than 2, you'll see I'm actually going to get back like this weird expression thing. And so even though it doesn't know what x is, it's like, okay, cool. Well, x is something which fulfills this expression where this that refers to x is greater than 2, and maybe you could have like a few of these, right? And x is less than or equal to 4 or something. Like so, it's returning expressions, and this kind of like holds for. This should hold as well for like other things. Maybe it's x dot bar equals foo. Let's see how much I can do. That one's not going to work. Doesn't know what string is probably. Let's just try this beginning thing. So all makes sense soon. All right, so like, okay, so here we have an expression, right, saying the bar value on this, when you look it up, it should unify, it should be equals basically to foo. So the reason where this is relevant from like a performance standpoint is you can potentially use this kind of method to like pre-compute your rules. Like if you have a bunch of rules and they all have different, it's got a bunch of different conditions, but maybe what some of the input types are going to be, or like you have different points in the code where you're like testing for different stuff. You can potentially like pre-compile, like partially evaluate as much of the policies you can and return that expression, and then later off like finish off the whatever is like left to do. So in this case, all that's left to do is look up the value of bar and check that it's foo. So instead of having to go through and like evaluate the whole policy every time, you can just do the piece that's like relevant to whatever your inputs are. So that's probably where I think that's probably the kind of thing that we'll do. That will see like quite a lot of speed ups in the short term. And I think this is you're asking about this feature as well. So like the other use case for this is if you have we have some kind of like experimental work of converting these expressions to effectively like SQL queries. And we support this in a couple of like Python RMs like Django and SQL Alchemy. So if you have some data set and you're basically your policy is saying well the user is allowed to access all data where the data is public and the user's ID is the same as the data's owner ID or something. This all gets returned as like data.isPublic is true and data.owner ID is like whatever 1, so that's the user's ID. This comes back as like some expression. What am I getting to? Oh, true doesn't have a capital. This comes back as some expression. This is public and this owned ID is 1. Those expressions then get converted to SQL and like implemented the database layer, like to filter your data. And that's like how you can kind of like potentially perform authorization over like an entire data set and filter it down to just the conditions that should be true, like at the SQL layer. So again, it's like these kind of pieces, this stuff will be like probably spending more work on to get performance improvements, more so than compiling to bytecode, because like the Rust policy core itself is pretty damn fast. The pieces where it's potentially slow is if it's doing lots and lots of these checks, like every time access the data. A bit of a segue into some other parts of the language.
All right. Well, thank you, Sam, so much for giving this talk. This was great.
Thanks all for coming and listening.
We are always looking for speakers. So if any of you are interested in speaking at the Rust meetup, it doesn't matter if you're in Denver or not. We're remote to stay as far as I'm concerned. Send me a message. You can find me at Twitter at Brooks_Patton. I know, Sam, you already put out your links everywhere. I also forwarded those into the Twitch chat.
Nice, thank you.
All right. Well, with that, I'm going to declare another successful end to the Rust meetup. I'm hoping that we all have a great rest of the day and a great rest of the week.